Bitcoin. Bitcoin is a monolithic UTXO, unspent transaction output, stack. It does not recognize accounts or balances in the code. Instead, it tracks discrete state objects. Every transaction is atomic, meaning it physically destroys an old digital envelope and mints a new one. The ledger isn't a spreadsheet, it's a conservation of energy law applied to data. It utilizes the Nakamoto consensus. Every 10 minutes, the network performs a difficulty adjustment. Miners compete to find a nonce that, when hashed with the block header via SHA-256, produces a value below a specific target threshold. This is thermodynamic finality. To rewrite history, you must physically reverse the entropy of the network. It is the only ledger anchored to the physical cost of joule seconds. The 10-minute block time is a physical synchronization buffer. It is the time required for a truth to travel through fiber optic cables to every node on Earth, accounting for network jitter and clock drift. It ensures the entire planet stays in the same dimension of time. Future applications include the global sovereign root of trust for land registries and national identity.
Ethereum. Ethereum is an account-based state machine. It functions as a singular global world brain known as the EVM, Ethereum Virtual Machine. Structurally, it relies on a Merkle Patricia Trie, a complex data tree that tracks every wallet balance and contract state simultaneously. Every transaction is a state transition function. Ethereum introduced Turing-complete smart contracts using Solidity. To solve the halting problem, where a program runs forever and crashes the network, it uses BAS, a physical pricing of opcode execution. Currently, Ethereum is deconstructing itself into a modular stack. It is moving the execution to Layer 2 rollups, which use recursive ZK snarks to compress 10,000 transactions into a single 32-byte validity proof. Ethereum's transition to proof of stake utilized the beacon chain to achieve economic finality. If a validator tries to lie, their stake is physically burned by the protocol. It is the first time a legal system has been hard-coded into a computer's kernel. Future application includes self-executing global insurance and decentralized autonomous legal courts.
Solana's structure is a synchronous parallel pipeline. Most blockchains fail because nodes have to stop and talk to each other to agree on time. Solana solves this with a Verifiable Delay Function, VDF, built into the silicon. This is POH, proof of history, a cryptographic clock that hashes time itself. Solana utilizes Turbine, a block propagation protocol that breaks data into small shreds to avoid bandwidth bottlenecks. It uses Gulfstream, which forwards transactions to validators before the current block is even finished. Its runtime, C-level, allows thousands of smart contracts to execute side-by-side, utilizing GPU-level parallelization rather than single-threaded CPU processing. Solana processes a hardware limit of 10 gigabit fiber. It is the first blockchain to treat network latency as a physical variable in the consensus equation. It is essentially a global high-frequency trading engine disguised as a ledger. Future applications includes DPIN, decentralized physical infrastructure, managing 10 million smart power grids and 5G antennas in real time.
Cardano. Cardano uses the EUTXO, Extended Unspent Transaction Output model. It takes Bitcoin's envelope security and attaches logic scripts to the envelopes. It is the only architecture built using formal verification, mathematical proofs that guarantee the code is bug-free before it goes live. It utilizes the Prouse consensus, the first peer-reviewed proof-of-stake protocol. Unlike Ethereum's global state, Cardano's state is local and deterministic. You know the exact cost and result of a transaction in your wallet before you send it. It uses Haskell, a functional language that physically prevents the side effect bugs that lead to massive DeFi hacks. The net gain here is hard fork combinator technology. Cardano can upgrade its entire protocol without ever breaking the chain or splitting the community. It is the move from brittle software to living biological systems. Future application includes unhackable national voting systems and digital sovereign IDs for entire nations.
Is a heterogeneous multi-chain metaprotocol. It is a layer 0 consisting of a central relay chain and specialized parachain. These chains are heterogeneous, meaning a gaming chain can speak to a medical chain through a common security umbrella. It utilizes Babe for block production and Grandpa for finality. They communicate via XCMP, cross-chain message pass. Polkadot solves the liquidity fragmentation problem, allowing independent chains to share security and data without needing dangerous centralized bridges. The secret logic. Polkadot uses nominated proof of stake, or NPOS. It uses a mathematical algorithm called fragmenti to ensure that validators are chosen fairly and that the wealth of the network is distributed to prevent centralization. It is a self-governing digital republic. Future application includes the Universal Health Data Translator, connecting private hospital ledgers to global research chains anonymously.
Avalanche. Avalanche uses a metastable consensus engine. It doesn't rely on leaders or blocks in the traditional sense. It uses recursive subsampling, a gossip protocol that reaches a tipping point of truth in under 2 seconds. Its structure is multi-chain, P-chain, governance, X-chain, trading, and C-chain, smart contracts. The Avalanche algorithm, Snowflake/Snowball, works like a subatomic chain reaction. Nodes ask 20 random neighbors, "Is this valid?" They respond, and the node asks 20 more. Within milliseconds, the entire network tips into agreement. This provides sub-second finality, the fastest in the industry. The aha detail: Avalanche is the only architecture built for horizontal scaling via subnets. A bank can launch a private blockchain, choose its own validators, and set its own legal rules, while still being physically anchored to the security of the main Avalanche network. Future application includes institutional asset tokenization, turning skyscrapers and cargo ships into liquid digital fractions that trade 24/7. Cosmos. Cosmos is a treaty between sovereign states. It uses the Tendermint BFT engine to allow independent chains to maintain their own validators while sharing a common communication protocol. The core logic is IBC, or inter-blockchain communication. It acts as a TCP/IP port for blockchains. It is designed for horizontal scalability, where chains opt in to talk to each other without giving up their sovereign security or their crown. Cosmos pioneered the app chain thesis. It argues that one chain for everything is a failure. Instead, every application, like a decentralized exchange, should have its own dedicated blockchain. This prevents congestion contagion, where a popular NFT drop on one app crashes the bank for everyone else. Future application includes global supply chain optimization between independent corporate nations and autonomous trade zones.
Monero is a base layer encrypted ledger. It is a forensic null set, a ledger that physically refuses to leak metadata. Privacy is a mandatory consensus rule hard-coded into the heart of the code. To build this void, Monero uses a 3-layered shield. First, stealth addresses use an ECDH handshake to ensure the receiver's address never appears on the ledger. Second, ring signatures mix your signature with 15 random decoys, creating signer ambiguity. Finally, Ring CT uses Pedersen commitments and bulletproofs plus. Ring CT is a zero-knowledge range proof. It allows the network to prove that the amount of money entering a transaction equals the amount leaving it, without ever knowing what the actual numbers are. To an FBI node, Monero is the event horizon. Data enters, but nothing ever comes back out. Future application includes confidential corporate intelligence and total financial privacy for citizens in a world of CBDC surveillance.
IOTA. IOTA is not a blockchain. It is a DAG, directed acyclic graph. Structurally, it is known as the tangle. Instead of a single line of blocks, it is a web of interconnected transactions, where the concept of a miner does not exist. In the tangle, to send a transaction, you must first verify 2 previous transactions. This uses a Markov chain Monte Carlo tip selection algorithm. It turns the users into the validator. This removes the economic bottleneck of fees. As the network grows, it physically becomes faster, not slower, because every new user adds validation power. In 2026, IOTA uses MANA, a Sybil protection mechanism that measures the good standing of a node. It is the architecture of the economy of things, or IoT, where machines pay other machines in microseconds. Future application includes autonomous machine-to-machine payments, your car paying a charging station, or your fridge ordering milk automatically.
Celestia is a modular data availability layer. It has physically deconstructed the blockchain by separating consensus from execution. Celestia doesn't care what your smart contract does. It only cares that the data is available. The engineering breakthrough here is 2D Reed-Solomon erasure coding. This allows Celestia to expand data, making it impossible to hide even a single byte. It enables data availability sampling, or DAS. Because of DAS, a tiny smartphone can verify a 1 gigabyte block by only downloading a random sample of a few kilobytes. Using namespaced Merkle trees, an app only has to download the data that belongs to it. It is the transition from building isolated roads to a universal foundation of truth, allowing anyone to plug in a custom blockchain in minutes. Future application includes the hyper-specialized web, where every individual AI model or video game has its own private modular chain foundation.
Algorand is built on pure proof-of-stake, or PPAS. It solves the trilemma through a process called cryptographic sortition. It is the only architecture that is mathematically guaranteed to never fork. Most PAS chains pick a rich validator and wait. Algorand uses a verifiable random function, or VRF, to run a secret cryptographic lottery for every single block. 1,000 nodes are chosen at random to approve the block. The genius is in the security asymmetry. The hacker doesn't know who the lottery winners are until they have already broadcast the block. By the time time a hacker tries to attack a node, the node has already finished its job, and the network has moved on to a new random set of winners. It provides instant finality and is the only ledger capable of running a global stock exchange without a central point of failure. Future applications include global synthetic asset markets and high-frequency central bank digital currencies, CBDCs.